Okay. So, in last class we have derived this equation. If you see this equation, we try to we have to solve for this alpha 1, alpha 2 and alpha 3 and alpha p. Okay. So, one of the method is called autocorrelation method. Before I going to autocorrelation method, let us there is the functions that mean square error minimization give me this equation. Okay. Now, another things I can say how to find out the error. So, what is the error function? So, if you see E n is nothing but a m equal to minus infinity to infinity E n square m error mean square, this is the mean square error. So, what is this? This is nothing but a m equal to minus infinity to infinity S n m minus k equal to 1 to p alpha k s of n m minus k. Okay. So, if this is the mean square error square. Okay. So, if I execute the square a minus b square. So, a square m equal to minus infinity to infinity s of n m square minus 2 into m equal to minus infinity to infinity s of n m a into b k equal to 1 to p alpha k s of n m minus k plus k equal to 1 to p alpha k s n m minus k whole square m minus k. What is the square of this means k equal to L 2 p alpha L s of n m minus L. I can write square of this term. I can write two summation term with k equal to 1 to p and k equal to L to p multiplication x s l. Okay. Now, if I do that, then if you see what is this term, third term, what is this third term stand for? So, third term said that k equal to 1 to p alpha k s of n m minus k. So, sorry, that will be another summation which is infinite sum, which is nothing but this infinite sum will be there. So, infinite sum will be here m equal to minus infinity to infinity. So, here m equal to minus infinity to infinity k equal to p m minus k, another term is k equal L equal to 1 to L equal to 1 to p alpha L s n m minus L. Okay. Now, if I say this is estimation of S m is only S n m. So, I can write this is equal to m equal to minus infinity to infinity k equal to 1 to p alpha k s of n m minus k into S m into S m. So, this term I can replace here. So, if you see 2 into the same term, one term, so 2 will be cancelled. So, I can say that E n is nothing but a E n is equal to m equal to minus infinity to infinity S n square minus m equal to minus infinity to infinity k equal to 1 to p alpha k s of n m minus k into S m. Okay. If it is that, then I can say it is nothing but a phi n 0 0 S n square means S n of m into S n of m. So, I can say I and k both are 0. So, both are 0 I can write minus k equal to 1 to p alpha k phi of 0, k. I is 0 and k is there, phi of 0 k. So, I can say E n is nothing but a phi n 0 0 minus k equal to 1 to p alpha k phi of 0 k. So, prediction error E n, I can, if I know the phi n matrix for 0 0 minus k equal to 1 to p alpha k predicted coefficient into phi of 0 k. So, this is one equation number, you can say equation number 2, and first equation as we have derived phi of I 0 is equal to k equal to 1 to p alpha k phi of n I k. Okay. This is one we have already derived. So, using these two things I have to find out the set of value or I have to solve that matrix. So, first method is called autocorrelation methods. So, what is autocorrelation methods? Now, before go to the autocorrelation methods, that if you see, if I take the whole speech signal at a time and try to find out the estimate the value of alpha 1, alpha 2, alpha 3, then my purpose is not served. Because if you know a speech signal is not a stationary signal, so it can consist of different type of signal with respect to time. Sometime it is voiced, sometime it is unvoiced, sometime it is sibilant. So, what I want, if I take that all voiced, sibilant, silence at a time and try to find out the set of alpha 1, alpha 2, alpha 3, there is no use, because whole signal is set and I do not know whether this time I have to supply the impulse response or this time I have to supply the noise, I do not know that. So, since the speech is a time varying signal, I try to modulate or try to take the signal for a small window where I can consider, this is a time invariant signal, that we have already discussed in time domain methods. So, that is why I take a small window from the long speech signal and within that window I consider speech property is not changing. So, it is a time invariant signal. Okay. If I take that, then I can say the speech signal, if you see this, that the speech signal which I have taken S n m is nothing but a infinite series of S m multiplied by a window function whose vicinity is between 0 to L minus 1. So, for a long speech signal, this is the nth window. So, here m equal to 0, nth window. So, here m equal to L minus 1 and where n plus, this is nth window. So, it is, if the starting point is n. So, suppose I have this is the first window. So, the from starting point is 0 signal up to let us 160 sample, 159 sample, 160 sample period window. Okay. Next window will start from 160 sample to that signal. So, I can say if it is frame rate is 10 millisecond, then I can say overlap signal. So, first window maybe I had taken 160 sample, then shifted the window by 80 sample and I take the window from here to here. So, this is my nth window where I take m equal to 0, my window length is L. So, outside the window length, I consider the signal is 0, there is no signal. So, there is a speech signal outside the window length, signal is 0. This is a very, you can say this part is idea, I mean this part is a concept. What is the concept behind that autocorrelation things? So, I can say I take a small window of signal, outside the window the signal is 0. Now, if it is that outside the window signal is 0, within the window signal is there. So, this is m equal to 0, this is m equal to L minus 1. Now, so if I want to predict, I said the linear prediction means I am to predict the current sample from the previous sample. So, if I say that I take the p point predictor alpha 1, alpha 2, alpha p. So, suppose I want to predict the first sample in here. What is the previous sample? All are 0. So, from a 0 sample, so all S n minus 1, S n minus 2, all S n minus p, all are 0. So, what is the linear combination of those 0? I get always 0, but first sample value is not 0. So, first non-zero sample value, let its value is something x. So, what is the total error? 0 minus x, or again sorry x minus 0, nothing I can predict. So, total signal, total sample itself is the error. So, I can set that at the beginning of the prediction error will be maximum. If I see the error signal at the beginning of the prediction error will be maximum, because if I say here my window is started, this is my sample, and outside the window signal is 0. So, because those samples are not there, I forcefully make them 0 by windowing. So, once make them 0, I am estimating the first sample from the all 0 sample. So, I get the estimation 0. So, the error is the sample 1. Take the next sample. I am estimating the next sample from previous p sample, where only one sample is there, which is S n minus 1 is non-zero. So, my prediction will be alpha 1 into S n minus 1. Okay. Then also error will be maximum, because this is not linear combination of all sample. So, once I move towards this inside the window, my prediction error will be minimize, okay, minimum. Again, when I want to exit from the window, so I have a L minus 1 sample, but I have pth order. So, from last sample, if I take the last sample is this one, last sample is this one is the last sample. So, I can say this is my window, this is the first sample, this is the second sample, this is the third sample, this is the last sample, then this is the previous last sample, this is the previous last sample. So, once I predict this side all are 0, all are this side also all are 0. So, once I predict this one from 0, in the error, maximum error I will get. I want to predict this one all 0, but one sample is there, error will be slightly reduced. I want to predict this one from 2 non-zero, slightly reduced. So, once I go towards the window, my error will be decreasing. Once I come in the end sample, then what I want to predict 0. This is my current sample is 0 from the previous p sample. So, current Sn is 0. So, linear combination of previous p sample cannot be 0. So, I can say there will be a error which will be maximum. So, there will be error in here also. All kinds of error may be positive, negative, I do not know which kind of error it will be. Maximum it will be negative error. So, error will be maximum at this point also. So, if I see the error plot, it started from 0, E 0, and I get E L plus P minus 1, because I have to go P sample this side also. So, my order of the my error length is E L plus P minus 1, because L minus 1 is this sample, P order will be added here. Okay. So, this is called LPC error. So, if I see the LPC error, beginning of the window LPC error will be maximum and the end of the window LPC error will be maximum. If I make the signal windowed by a window, any window, any kind of window you can say the window. So, outside the window the signal value is 0, I am not considering the sample value. Okay. Now, if I do that, then what should be my equation? So, my equation En is nothing but a m En square m. Now, if you see m I do not have, so where is the error vicinity? Error can vary from 0 to L minus 1 plus p. So, there is no infinite error series, I can say this is varies from m equal to 0 to L 1 minus 1 plus p En square m. So, there is no infinite signal length, I have a signal length which varies, error varies from L minus 1 plus p En square m. Now, I know phi n I k is equal to m S n m minus I and S n m minus k, where 1 I p 1 to k p, k varies from 1 to p, I varies from 1 to p. Okay. So, now S n m outside the window is equal to 0, which is only non-zero if m varies from L minus 1. Okay. So, I can say phi I k is nothing but a m is equal to 0 to L minus 1 plus p S n m minus I S n m minus k. Okay or not? If it is that, now if you see that this phi extraction of phi I k only possible if I see that this is my, let us this take that S n minus, let this is my window, let this is the window of, this is S n minus m minus k. Okay. So, k equal to 0 to, so this is the m n minus k of window length. Okay, m equal to 0 to L minus 1, and let us this one is my this one is my m equal to 0 to L minus 1 S m minus I. So, only the overlapping region will contribute to the calculation of value of phi I k. So, I can say that value that phi n I k I can rewrite m equal to 0 to L minus 1 plus I minus k S n m plus I minus k. I can rewrite this one. Okay. M minus f. So, phi I k. So, if I see I minus k is equal to tau, let us tau sample kind of tau time. So, I can say phi I k is nothing but a R n I minus k is equal to R n tau. So, I can say R n tau is nothing but a m equal to 0 to L minus 1 plus tau S n m into Sn m plus tau. Okay. So, if it is that, what is this? What is the correlation between the two signal, or the correlation between the two signal? If it is xn and yn plus L, RL is equal to m equal to 0 to L minus 1. So, I can say this is the correlation of tau or n tau. So, if it is tau equal to 0, then it will be R 0 is equal to m equal to 0 to 1 L minus 1 plus 0 Sn m plus tau. Okay. So, I can write down that let us from equation let us take the equation 2, which is the equation 2? Equation 2 is phi I 0 is equal to k equal to 1 to p alpha k phi n I k. This is the equation number 2. So, we have already derived from here. So, now from here if I write down, then I can say k equal to 1 to p alpha k phi I k is nothing but a phi n I 0. So, I can say this is nothing but a k equal to 1 to p. Instead of phi n I k, I can write R n I minus k is equal to phi n, or I can say R n I minus k is 0. So, I can say R n I. Okay. Now, from the mean square error, if you see the mean square error equation we have derived. So, mean square error E n is nothing but a phi n 0 0 minus k equal to 1 to p alpha k phi n 0 k. So, that also can be written R n 0. So, phi n is replaced by R n, which is autocorrelation, minus k equal to 1 to p alpha k R n k only. I is 0. So, R n k only. So, I can say E n is nothing but a R n 0. So, now if it is R n 0, what is so I can say the R n 0. So, if I know the R n 0, I can write down the matrix, this matrix from this equation. From this equation I can write down the matrix. So, I can say R n 0 R n 1 dot 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 R n p minus 1, this side R n 1 dot 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 R n p minus 1 R n 0 dot 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 R n p minus 1 equal to alpha 1 alpha 2 alpha p is equal to R n I. So, I can say R n 0 R n 1 dot 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 R p R n p. Here you say, here k I and k are there. So, I equal to 0, I k equal to 0, R n 0 minus 0 0 1 dot p minus 1. Here I equal to 1, then it will be 0 p minus 1. So, that way it will come. So, if it is that, if I solve this, so I can say R. So, if you see the R into alpha, if it is capital R is this matrix into alpha is equal to R. So, alpha is equal to, so if the capital R is the matrix and R into alpha is equal to small r, if it is this is called small r matrix, then I can say alpha is equal to capital R inverse small r. I can solve. So, all diagonal element, if you see the R n 0. So, this has a special type of matrix. So, symmetric with all diagonal elements are equal. So, matrix equation solved using, then I can apply the Levinson-Darwin algorithm to solve this matrix equation. Okay. So, next class we try to discuss how we want to solve this matrix equation. So, if you see that R n I have established here that R n is nothing but a autocorrelation. Okay. So, instead of phi I m, I have to know R n 0. So, what is R n 0? R n 0 is nothing but a first R 0 or R n 0 is nothing but a, if it is L number of sample. So, let us k equal to 0 to L minus 1 x of k into x of k. Now, what is R n 1? Is nothing but a k equal to 0 to L minus 1 x of k into x of k minus 1. So, I can calculate those autocorrelation R n value easily from the given signal and put in this matrix, and using Levinson methods that I can solve this matrix for value of alpha 1, alpha 2, alpha 3 and alpha p. So, instead of writing phi I k, I am now writing in autocorrelation. This method is called autocorrelation methods based LPC coefficient analysis. So, next class I will try to derive those 3 Levinson recursion equation by which this matrix can be solved using this type of autocorrelation value. Okay? Thank you.